Hello all. So welcome to the second class of highway engineering. I hope you might have seen the previous video in which we did a quick revision of what we discussed so far in our regular classes, and I also introduced a topic of highway geometric design of your horizontal alignment. So this session onwards we are going to discuss more about the geometric design aspects of horizontal alignment. So just to begin with it, I think it's better to give an overview of what is that we design under horizontal alignment. So we said highway alignment, there are like it can be horizontal alignment, vertical alignment. When I say horizontal alignment, my straight path or whenever there is a change in direction request, it covers by a horizontal curve. So these are the two coming under your horizontal alignment. And why this geometric design is important? Please understand that when your vehicle traverses a curve, just imagine that if it is a very sharp curve, there are chances of either overturning or skidding, so that is not safe. So geometric design aspects knowledge or knowing the how to design is very much required. Okay, now let's recall what are the factors we discussed. We said there are a couple of elements which are you need to understand the depth of it for your geometric design aspect. The very first of it was the design speed. What is the speed in which you are traveling? For that you should have a knowledge about your terrain condition as well as what is the type or the class of the road. So am I talking about a mountainous or a steep terrain, or am I talking about a design of my village road or on a national highway? So this is what is something called as the design speed. Elements are going to depend upon, and we introduce something called as a ruling design speed, that is a design criteria. So wherever possible, attempt has been made sure to meet the ruling design speed, and if there is any constraint, one can opt for the minimum design speed. So this is what I guess we ended up with in the previous session. Now this session I'm going to talk about when we say a vehicular movement on a curve, what exactly happens to your vehicle. That knowledge is something you should have before we talk about other elements like what is super elevation or widening of your pavement, or what is your transition curve. Let's understand the mechanism behind it. So so imagine what is a curve. So I have a straight path. Okay, let's understand the sketch properly, and I'm going to introduce, I just want to have a change in my direction. So there comes my horizontal curve. So this is what exactly I want to draw. And now imagine on your curve. So let's draw this curve in a perfect way. Okay. Now this is what I meant by an horizontal curve. Now one aspect, please be clear, how should I designate my curve? So you can either use, see, for a circular curve, so there may be somewhere in its center. I'm just marking this as my center of the circle, and I can either tell in terms of its radius. Okay, so I can take it as the radius, or I can even use its angle, that is degree of curve. So I can use either degree of curve or I can use radius to designate my circular curve. Now, so radius is something everybody knows. Now let's understand what do you mean by a degree of curve. The degree of curve is nothing but what is the central angle subtended. So you can see that the angle subtended. The most important thing you need to understand by an arc of length. When I am drawing this, it's an arc, right? So arc of length of, this is what the most important thing, of an agreed length. See here there is a clause, because this agreed length can be varied under different ways one can consider. For example, US is generally taking this arc length as 100 feet. So if I'm converting into like meters, I can say like 30 meter. So I'm just saying like what is the central angle subtended by an arc length of 30 meter. That is what is degree of curve. So one can either designate a curve by in terms of its radius or in terms of the angle it is. That's called as a degree of curve. Now, can we make a relation? Yes, it is possible. Let's understand the basic thing. If this is my degree of angle subtended, I'm going to take it as D divided by, I know that the entire circle is around 360 degree. So D by 360 is equal to, what is that? 30 which is the agreed length divided by the perimeter of it, 2 pi r. So one can establish a relation, that is degree of curve with respect to the radius. So this is how generally we designate a circular curve. Okay, so I hope that is clear. So one can utilize either r, radius, you can tell in terms of r, or you can talk in terms of the degree of the curve. Now let's understand, if my vehicle is on a circular curve. So vehicle is traversing a circular path. Now let me make one point clear. When we talk about a circular curve, I am talking about a plain horizontal curve. That means there is no super elevation. Please understand, we have on curve, especially on curvature, we do have the practice of raising the outer edge. So we will discuss about super elevation in the coming classes. So I am not talking about any kind of super elevated road here. This is a plain curvature. That's what I meant here. Okay. So let me just write it here itself. Now assume that this is your horizontal curve. This is probably the inner curve, inner side of it, and this is my outer edge. Okay. So I hope that's clear. This is inner and this is outer edge. Now assume that our vehicle is somewhere over here, my car.
Start.
So my car is traversing my circular path. Okay. Now please recall the physics which you have studied, like when an object is moving on a circular path, what is the tendency it is going to happen over there. So on my circular path, my vehicle, there is an apparent force which acts and it has a tendency to push the body or the car outside, away from the center of gravity. So we call this force as your centrifugal force. You remember the centrifugal force and the centripetal force you have studied when we are talking about a moving object on a circular path. So this centrifugal force always acts outwards. So it has a tendency to push this vehicle outwards. Okay, and how do we maintain the stability? So to have for this car to traverse this path under its speed and having to maintain its stability, there should be an equal and opposing reaction, opposite force, and that is what we call generally as the centripetal force. In this case here, what will happen is it's friction. So how this frictional force is developing? Your vehicle tire and your road surface, pavement, and there is a rubbing action between the tire of your vehicle as well as the pavement surface. So that frictional force acts as a resistance and it will try to maintain the stability of the vehicle. So this is what it is going to happen. So please understand, on a circular path there is a centrifugal force which plays a major role to push your body through outside, okay, outwards. So that how now which ways it can happen, that's what we are going to see. When I say like push the body outwards, what is that? It can either turn, we call it as an overturning, or it can either have a skid. So we will say it as a skidding and we'll call it as overturning. These are the two possibilities here, and we are going to see like how it is acting and how this centrifugal force or the frictional force is come into picture in deciding when it will overturn, when it will skid. Now this centrifugal force I am going to call it as P. Now I know that my vehicle is moving with a speed of V in meter per second I am saying, and I have my radius of curve as R in meter. So let's write our centrifugal force equation. P is equal to W V square divided by GR, where P is nothing but the centrifugal force in kg, W is equal to my weight of the vehicle in kg, and V is the speed of my vehicle in meter per second, G is the acceleration due to gravity 9.8 meter per second square, R is the radius of the curve. So centrifugal force is depending on what is the speed with which you are traveling and what is the available radius over there. Okay, now so having understood this, I am slightly going to rearrange this because I'll introduce that factor here. I'm just going to take this weight of vehicle over here. So this is P by W. P by W. is equal to V square by GR. This P by W is called as centrifugal ratio or impact factor. Let me write it on top. Centrifugal ratio or impact factor. So what we analyze is that what is P by W ratio for overturning, what is the P by W ratio at the skidding, and how it is related to the frictional force. That's something you need to have an idea about it. Okay, so I hope this is clear. P by W, you can either call it as an impact factor or centrifugal ratio, and it is at V equal to V square divided by GR. Now, let me quickly erase this. So we understand that on a circular path, a vehicle, it experiences centrifugal force and it has a tendency to either overturn the vehicle or to skid the vehicle, and the centrifugal force equation is P is equal to W V square divided by GR. Now let's understand when this overturning is happening, when the skidding is happening. Okay, so first let's consider the case of overturning the vehicle. Now, for that, I think we can draw a sketch of this is my road surface, and I am going to draw a vehicle, and this is the wheelbase. Now, this is my center of gravity. There exists a force, centrifugal force, which we denote it as P, the centrifugal force P acting outwards. Now, there is a weight of the body that is acting downwards, vertically down, weight of your vehicle in kg. Now, let me introduce two terminologies here. One is B and another one is H. B is nothing but the width of the wheelbase. H is a distance from your road surface to the center of the body. Okay, so let's mark that. Since this is the entire width is B, so I can mark this as B by 2 over here because that is the center point we are taking, and this is B by 2. Now, towards this point from the road surface, I am calling this distance, this height as H. Okay, so I guess this free body diagram is clear to you. The centrifugal force P acting, and the vertically down its weight is acting. The width of the wheelbase, since it is a center point, B by 2, B by 2. So B is the width of the wheelbase and H is the distance from which we are considering this center of gravity of the point. Now, so how the overturning is happening? So overturning means the outer wheel, that is where there is a tendency to turn, right? So this is the outer edge and turning is happening. So we are introducing the moment concept here because I know there is a force and there is a tendency to rotate my body. So we are seeing here what is a moment happening over here, typically calling overturning moment, and which is the restoring moment happening, which is allowing my vehicle to keep it in its position. So let's calculate our overturning moment. Please follow it in the sequence so it will be easy for you to understand. So my overturning moment is because of P, because that is the external force. Now what is moment means? Force into perpendicular distance. So this is my force P and my perpendicular distance is nothing but the H, right? So this is the point we are considering the moment. So P into H. P into H. Now let's consider what is restoring it back. My weight of the vehicle is trying to produce a moment which is acting as a restoring moment. So let's write the restoring moment due to weight of the vehicle W. So restoring moment is because of W. So here my force is W. So my perpendicular distance will be B by 2. So which is equal to W into B by 2. Okay. So you understood that this is the overturning moment, this is the restoring moment. Now, what is that we have to look at here? Derive into your equilibrium condition. So what is equilibrium condition? I should equate these two. So I am going to equate P into H, both overturning and restoring force. So P into H is equal to W into B by 2. So what is P by W? Why I am writing P by W? Please recall, we said centrifugal force is P, and we also derived a relation, impact factor or centrifugal ratio, as P by W. So we are now deriving the criteria from here and going to correlate with it and seeing, like, when this overturning is happening. So P by W is equal to, my H will come to this side, so it will be B by 2H. What is the meaning of it? When my PWD value, that is when my centrifugal ratio is coming close to B by 2H, I am in danger because there is a chance for overturning. I hope that is clear. So my P by W, I have to make sure that the maximum value, beyond that if it is going, I am in danger because the vehicle has a tendency to overturn about its outer wheel. Okay, so let me write this equation on one side and we will see in the same scenario the other case of skidding. So I am just going to write on this side P by W is equal to B by 2H, which we derived for the overturning, the first case. Now I am going to write about the skidding, the second skidding. So I said it can be either overturning or your vehicle has a tendency to skid, right? Now think about when the skidding is happening and what is actually resisting it. So let's draw the diagram again. So here let's draw the vehicle and the wheelbase. Okay, so I'm going to draw my road surface. So again the same condition, this is our inner edge, this is our outer edge of the curve. So this is your center of gravity and there acts a force outwards, that's your centrifugal force. Now centrifugal force is, here we are not talking about overturning, we are going to talk about skidding. So skidding happens outwards, right? So there is a tendency to skid the vehicle laterally or in a transverse direction. Now what is resisting it? It's not your weight of the vehicle. This is the friction that is developing between the tire of the vehicle and between the pavement surface. So between the tire and the pavement, the rubbing action, so that friction is acting as an restoring for against your skidding. Now let's draw the free body diagram little more carefully. So I'm drawing its weight vertically down. Now we all know that frictional force develops. So friction means what? It's always opposite to the motion. So this is P is the force in this direction. So friction will be in the opposite direction. But before that, please understand this is my outer wheel B and this is A. Okay, B and A. Now I have a reaction over here. I have a reaction under my wheelbase over here. And I did carefully, I just drew a very small reaction over here and this reaction is compared to A slightly higher. Because we know that the effect of the frictional force is more on the outer edges, that's why the reaction developed here is higher than compared to A. Now, so I know the reactions are happening. First, let's draw the reaction. So, how the reaction? Reaction means vertically upwards. So, weight is acting downwards. Normal reaction. So, this is reaction at B, which I am calling it as RB. Reaction at A, I am calling it as RA. Okay. Now let's talk about friction. So, friction is in the transverse direction. So, P is acting. So, opposing to it is my frictional. Since the reaction develops are different at different places, I am going to write friction develops at B and friction develops at A. So let's write friction develops at B. Please note that I am marking this opposite to the direction of P. So I am getting my friction force B here and frictional force A here. Can we slightly expand it? We all know this frictional force is coefficient of friction into normal reaction. The normal reaction here is B. So FB is equal to F into RB, coefficient of friction into the reaction applies over here. Similarly, FA is equal to coefficient of friction F into RA, because this is the friction, this is the reaction develops at A. So FA is equal to F into RA, frictional force at B, opposing to the your centrifugal force. These are in the lateral direction, and perpendicularly you have weight acting down, and this is two reactions acting upwards. Now we have done the similar manner which we did for the overturning. Let's consider the equilibrium cases here. So I am going to resolve here in the horizontal plane as well as in the vertical plane. So in the horizontal force, let's write the equations. I have two forces, one P outwards and two forces coming inwards. So I am going to write P is equal to, which are the two forces? FB plus FA. So FA plus FB. Now, since you know it what is FA and FB, let's write that full form, that is coefficient of friction RA plus frictional coefficient RB. And we know that F is a common term, so we can take it out. So it will come RA plus RB. Let's stop here and see in the vertically what is happening. So vertically I have weight of the vehicle is acting down. To compensate it, there are two forces, like two normal reactions acting upwards. So if I am resolving the forces in vertically, W is equal to RA plus RB. Okay, now just go back here, because I got RA plus RB as weight of the vehicle. So I can replace this equation as FW. Okay, so can we write it together? So please understand, we are here. Now P is equal to FW. Let me rewrite it again. P is equal to FW. So what will happen to P by W? Because we are interested in centrifugal ratio. The P by W is equal to F. This is the criteria you are coming over here. So what is the meaning of it? As I said, when your centrifugal ratio is limiting to your frictional resistance, then you are in danger. Because skidding may happen if the value is exceeding your F. So let's write the second condition we have derived, which is equal to P by W is equal to F, friction. Okay. So to summarize it, the meaning is that circular motion, you are getting a centrifugal force. So we take centrifugal ratio as our parameter, and this centrifugal ratio, if it is approaching to a value of B by 2H, then you can say the overturning takes over there. And if the P by W is approaching F and going above that, then I have skidding as a major problem. So the lesson you learned here is that to avoid both overturning and skidding, what is that you have to make sure that? You have to make sure that your centrifugal ratio P by W is less than B by 2H. And here the centrifugal ratio P by W should always be less than F. Another important factor I want to highlight here, that the lateral skidding on horizontal curve. Please understand, I told in the very beginning, we are emphasizing on plain horizontal curves. There is no super elevation at all. So frictional resistance is the major factor which is ruling here, because whether the skidding happens or not, if there is no elevation. Now, so this is the criteria for us. Make sure that P by W is always less than B by 2H and always less than friction. Now, let's take this equation again, that is P by W is equal to V square by GR. Imagine a scenario in which your speed of the vehicle is quite high, and so your speed of the vehicle is higher and your radius of the curve is slightly lesser. So I'm just marking it as a lesser one. Okay. So what is going to happen to your P by dW ratio? It's going to increase, right? So it's going to increase to a certain extent. So there may be overturning, there may be lateral skidding. So how do we decide about such a situation? So in such a case, in such a situation, so you will look at the value of your coefficient of friction. If the coefficient of friction is less than your B by 2H, then the vehicle have the tendency to skid. If your B by 2H is lesser than your friction, then there is a chance for the vehicle to overturn. So the relative danger of skidding or overturning, it depends upon the value of your friction. So friction force is very much important when you are talking about an horizontal curve when there is no super elevation. Now I hope this is clear, like what is the mechanism or what are the kind of forces develops in a body vehicle when it is traversing a circular path, and what is the tendency of the body to, like whether it is when the overturning is happening, when the skidding is happening, the role played by coefficient of friction, the weight of the vehicle, everything. I hope that is clear in this video. Now the next video we will see like how the super elevation is helping here. Thank you.